you have a you have basis here. Okay, speak up. I cap, j cap, k cap. Okay. Hmm? You have basis here, psi n of x, which are also normalized orthogonal. Okay, speak up. Hmm? I will take one general vector. Okay, speak up. Hmm? And I will normalize that vector also, that general vector also. Okay, I'll take one general vector. I'll normalize that general vector also. Mod psi square. I mean, I'm saying vector. You can say it as a vector. Okay, in the linear algebra sense. Okay, dx is equal to 1. Hmm? Here, I'll take one general vector. Okay, which is a unit vector. Is that okay? I'll take one general function whose mod psi square integral that's equal to 1. Then we say it is normalized. We say it is a unit vector. A is a unit vector. Am I right? Because now I will expand this general function, okay, in terms of this basis, Cn into psi n of x. Am I right? Hmm? Isn't it? In the similar way, I will expand this A in terms of Ax I cap plus Ay j cap plus Az k cap. Isn't it? Hmm? Now, so A dot A equal to 1? Equal to 1. What is A dot A? Ax square plus Ay square, Az square. Someone mic is on. Any question? Isn't it? In a similar manner, okay, speak up. Mod psi square dx equal to 1. Isn't it? That means its dot product with itself equal to 1. That will lead to, you can prove that one. He proved that one. Okay, that will lead to summation over mod Cn square equal to 1. Hmm? If you take care of normalization in this step itself before expanding, you take normalized function, any function, normalized function. You are expanding in terms of again normalized function. Okay, then this will happen directly. You don't have to take care. Similar to you took a vector which is a unit vector. Okay, you expanded that unit vector in terms of unit vectors, orthogonal unit vectors. Coefficient square adding equal to 1. Very similar. Can you find the analogy here? Is that okay? And we can prove this one actually. We can prove this one. I mean, they may ask different parameters. Okay, but the state, whatever they mention, they can give in 3 different manners. That's what I'm saying. One type of problem, okay, speak up. They may give their initial state psi of x comma 0. That is one of the eigenstate. One of the eigenstate can also be initial state. Suppose psi 3 of x. Speak up. What is the state at later time? Speak up. That's equal to simply psi 3 of x into e power minus I e3 t by h. It's very simple. I don't think here they will ask time evolution. They will give this one. They may ask some probability. What is the probability of finding the particle in left half of the box? What is the probability of finding the particle from 0 to a by 3? Like that. Or what is the average value? Okay, like that. That kind of question they will ask here. They will not ask time evolution. It's very simple, isn't it? Because it's already written in terms of basis, isn't it? Time evolution is very simple here. Okay, speak up. Second one, they will give initial state. That's one of the problem. Okay, speak up. So suppose C1 psi 1 of x plus C2 psi 2 of x. Am I right? That is the problem he gave. I mean, in problem 2.5, he has given psi of x comma 0, that's equal to a into, okay, psi 1 plus psi 2. Speak up. This is another type of problem where initial state, whatever they mention, or state, whatever they mention, there's a linear combination state, but finite number of terms in the linear combination. 2 term, maximum 3 term. Maximum 3 term. Okay, and finding the time evolution. Or here they will start asking what is the probability of energy measurement. what is the average energy? Isn't it? Here, what is the probability of energy measurement? E3, we know that one. What is the average energy? E3. Speak up. That's why here they don't ask that kind of question. Here they will ask something related to probability, average value of position, average value of momentum, okay, like that kind of question. But here they will start asking what is the probability of getting E1, what is the probability of getting E2, okay, what is the average energy. These things they will ask here. Is that okay? Speak up. Or what is psi? Speak up. What is psi? X comma t. Okay, that is C1 psi 1 of x e power minus I E1 t by h bar, okay, plus C2 psi 2 of x, okay, e power minus I E2 t by h bar. Is that okay? Speak up. Now I will tell you normalization. I mean, this total state also should be normalized. Am I right? To do any interpretation, okay? That normalization you need to do in different way in this one and in the next problem. Let me tell you, okay? So third one, okay, speak up. They will give initial state. Given state is such that speak up. Psi of x comma 0, it contains infinitely many terms. N equal to, suppose n equal to, I'll write 1 to infinity, okay, Cn into psi n of x. They'll give some general function which cannot be decomposed into one or two terms of your basis, which contain infinitely many terms. Okay, speak up. Here also, they can ask what is the probability of getting, suppose E3. What is E3? Mod C3 square. Sorry, mod C3 square here, isn't it? They'll ask like this. I mean, they can ask any question. Or what is psi x comma t? I don't think they will ask psi x comma t because options would be very lengthy. To type 4 options. We know that one. Speak up. Psi of x comma t, that's equal to summation over n, okay, 1 to infinity, Cn into psi n of x into e power minus I En t by h bar. Are we done? Like that. Now, whenever they give that one, how do you take care of normalization? If they can ask probability of energy measurement or position measurement or something. Okay, how do you take care of normalization? Okay, in this kind of situation, you take care of normalization in this manner. Summation over mod Cn square equal to 1. Because you have finite number of terms. This will not be on infinite series. But in this case, if you try to take care of normalization by this one, this will be one infinite series. Mod Cn square equal to 1. This will be one infinite series. Rather than this one, why can't you take care like this? Mod psi x comma 0 whole square dx is equal to 1 because these two are equivalent. You choose this one. Pick up. Otherwise, it would be one infinite series, isn't it? But here, okay, here this will be only two terms actually. Am I right? I mean, in this case, mod C1 square plus mod C2 square equal to 1. Only two terms, isn't it? Mod C1 square plus mod C2 square equal to 1. You should somehow, you can multiply the total function, okay, by one constant. That constant he already mentioned, A. So that this happens. What is that A? Can you quickly guess? 1 by root 2. I by root 2 also. Why not? Speak up. Isn't it? Like that. You take care of normalization in that manner. Isn't it? And that is equivalent to, speak up this one. Am I right? Mod psi x comma 0 whole square dx equal to 1. These two are equivalent. Suppose unit vector, okay, given vector is unit vector. Or if you want to make it unit vector, normalization concept. Given one vector is characterized by direction, you want to make a unit vector. Okay, how do you make it as a unit vector? By making sure that A dot A or mod A square, Speak up, is equal to 1, isn't it? So that is equivalent to, this is equivalent to, I mean, once you expand this one, these are coefficient mod square, mod ax square. I mean, we don't write mod because these are real in the real vector space, okay? Plus mod ay square plus mod az square is equal to 1. Then also you say it is a unit vector, isn't it? You dot product, take dot product with itself and make sure that it is a unit vector, or later you expand and divide each and every term by one common factor and make sure that square and adding the coefficient, I mean your component, equal to 1. These are equivalent, am I right? You divide here by 1, or you multiply here by one factor, or divide by one factor and make sure of this one, or later you divide each component by one common factor or multiply each component by one common factor and you make sure these are equivalent, am I right? Make sure that it is 1, these are equivalent. Now what I am saying is this is equivalent to speak up, mod psi x comma 0 whole square dx equal to 1. Got my point? Because this is nothing but psi star into psi is nothing but kind of inner product or dot product, am I right? According, in orthogonality relation and all, we discussed that one, isn't it? Pick up, that's equal to 1. And this is equal to, pick up, after expanding psi of x comma 0 as summation over Cn into psi n, this expansion is equivalent to this one. This kind of expansion. Is that okay? Speak up. Now this is equivalent to, pick up, I mean coefficient mod square adding equal to 1, that is equivalent to coefficient mod Cn square summation is equal to 1. Am I right? Speak up. Now if this happens, this will definitely, look at it, if this happens, this will definitely happen in vectors. Am I right? Isn't it? If dot product with itself is equal to 1, am I right? Then this will definitely happen. Or if this happens, this happens. Exactly the same thing here. If this happens, this will happen. If this happens, this will happen. Can you grab the comparison here? Speak up. That should give you confidence. But remember, this is only possible when I cap, j cap, k cap are unit vectors. It's only possible when these are individually normalized. Normalized means in the linear algebra sense, unit vectors. Got my point? Okay. Be careful here. You should have kept normalized eigenvector there. Okay. Speak up. Let me quickly do this one. Okay. What is this one? Sine 3 theta is 3 sine theta minus 4 sine cube theta. Okay. Sine cube theta, that's equal to 1/4 of, okay, 3 sine theta minus sine 3 theta, isn't it? Now see this one. I will give you normalized wave function, okay, without doing any integral. Okay, speak up. Fine. So a here, okay, what is this one? That is 1/4 of so 3 times sine pi x by a minus sine 3 pi x by a. Am I right? Now to write in terms of psi 1 and psi 3, you can see psi 1, psi 3 here. Okay, I mean box is from 0 to a. Fine. Box is from 0 to a. Okay, speak up. Fine. So that's why what I do is I need root of 2 by a. Okay, isn't it? So that's why I will divide outside by root of 2 by a. Inside I'll write 3 into root of 2 by a sine pi x by a. Okay, minus sine root of 2 by a sine 3 pi x by a. Got my point? Because I wanted to write, look at here, this way of normalization is right only when psi 1, psi 2 are individually normalized. Can you recall? So that's why what I needed here is I needed normalized wave functions here. Okay, speak up. So now what I do is this root of 2 by a 1 by 4, everything together, I'll say some b, a prime or b, I'll say constant b. I'll find b later by normalization. Okay, what is this one? 3 psi 1, okay, minus psi 3, isn't it? Now I'm going to write it as, okay, 3b into psi 1 minus b into psi 3. I'm going to see it like c1 psi 1 plus c3 psi 3. Now what is the normalization term? Mod c1 square plus mod C3 square equal to 1. Speak up. That's nothing but, so 9 into b square plus b square equal to 1. Okay, 1 by root 10. 1 by root 10. Okay, speak up. Now this is my normalized wave function. 1 by root 10, that is my b, okay, into 3 psi 1 minus psi 3. Now you can see the coefficient. This is normalized one. Now it is free. You are free to do further part, like probability of energy measurement outcome, that is either E1 or E3. Got one point. With probability 3 by root 10 the square and 1 by root 10 the square. Okay, pick up. Using that one, you find probability of finding E1, probability of finding E2, and average energy. That's equal to, can I say, mod C1 square E1 plus mod C2 is not there, C3 square E3. You got it? No integral, only algebra. And they may ask again time evolution. You just plug in that e power minus I et by h bar. Okay, speak up. So try to grab this clear-cut answer so that you will have some confidence. Now look at here. So I mean, while doing the problem, I don't even do this one, dividing by root of 2 by a. Okay, multiplying by root of 2 by a. I can throw, the whole term, I'm free to multiply with any constant without changing their weightage. Okay, the whole term you are free to multiply by any constant. You are anyway taking care in the normalization. Okay, it was just for my comfort, like throwing in root of 2 by a and dividing by root of 2 by a. It was just for my comfort. You got this idea? Speak up. Solve it again. Now this is YK-limb problem, which is asked in one of the CSIR-NET exam. I think you might have seen, isn't it? Particle of mass m confined to one-dimensional region 0 to a. Particle in a box from 0 to a. Okay. Its normalized wave function is given like this. Okay. Psi of, what is the average energy of the system? How do you do? First thing is you need to normalize. He said it's a normalized wave function. Don't believe. Sometimes some mistake may happen. You may need to normalize to get into right answer. Okay, you just check the normalization always. Okay, now look at here. So psi of x comma 0, it is given. This is not stationary state. This is not definite energy state. Definitely, isn't it? Definitely, it is not definite energy state. Okay, so this is a linear combination state, isn't it? Now what will you do? We again you just work out some trigonometry to write it in terms of linear combination state. Don't go for any integral. Okay, so suppose if it is, again, if you wish to find normalization constant, okay, if normalization constant was not given, if you wish to find normalization constant, again you go with what you call some algebraic step, not integral. Is that okay? Speak up to check normalization also. Okay, we shall see that one. So now again you can just rearrange this term, root of 8 by 5a, okay, sine pi x by a into plus sine pi x by a cos pi x by a. Okay, let me explain some more logic here. Okay, from one problem, if we grab more, then I think you can apply the same logic to other problems. Okay, speak up. So can I write as 2 divided by 2? 2 sin theta into cos theta, sine of 2 theta. Am I right? Root of 8 by 5a. Okay, sine pi x by a plus sine of half of 1 by 2 sin theta into cos theta is sine of 2 theta, sine of 2 pi x by a. Am I right? Speak up. Now you can think of some rearrangement. Am I right? Again, again, I need root of 2 by a inside. Am I right? Speak up. So that's why what I do is I'm going to write root of 4 by 5. Okay, root of 2 by a. Can I write like this? So that I can take root of 2 by a inside, isn't it? So if I take root of 2 by inside, root of 2 by a sine pi x by a, okay, plus half root of 2 by a sine 2 pi x by a. Am I right? Now what is this one? This is psi 1. This one psi 2. That's equal to root of 4 by 5. What is root of 4 by 5? 2 by root 5. 2 by root 5 psi 1 plus half psi 2, isn't it? This is equal to, so 2 by root 5 psi 1 plus 1 by root 5 psi 2. So check whether the state is normalized or not by squaring and adding these two terms. Mod square and adding. 4 by 5 plus 1 by 5. That's equal to 1. It is normalized. Now, if suppose this term was not given, let us try to grab as much as possible from the problem. Suppose if this term was not given, what would you do? Just think over it. This term was not given and you need to find this one, suppose. Speak up. Then what will you do? This is also some constant, am I right? Root of 8 by 5 is also constant, am I right? Speak up. Suppose if this term was not given, how do you find it? You will end up with this step, am I right? You just do some trigonometry here, you will end up with this step. Now you need root of 2 by a, root of 2 by a here, am I right? Speak up. You just throw that term because this, look at here, this is a linear combination state, okay? If you multiply the whole term by a constant, its physical property will not change. Later you are going to normalize. This is very equivalent. Look at here. This is a linear combination state. Am I right? Look at here. It's very equivalent. Again, whatever this linear algebra kind of question, if you have any doubt, go for your arrow vector algebra and get it so clarified. You will have an analogy there. Okay. Suppose if I have a vector, that vector is not normalized. First, what I do is I'm going to write that vector as some ax into I cap plus ay into j cap. Am I right? Speak up. Suppose this is I cap, this is j cap. I'm going to write in terms of I cap and j cap. Am I right? I mean, exactly in the similar way, this should be seen as, okay? So these are the kind of bases, okay? Like that you have to see, okay? This is a vector actually. So these are its bases, I cap, j cap. Not exactly, wait a second, I'll come to that point, okay? Now look at here. So if you have a vector, again, it has ax I cap, ay j cap. Am I right? Again, you have written in terms of linear combinations of what you call I cap, again, vector along I cap, vector along j cap. Am I right? Now, if I multiply this whole thing by something, some scalar, suppose c into ax I cap plus c into ay j cap. Am I right? That's nothing but c into a. This will change the direction of vector? No, isn't it? If you multiply by a scalar, it will not change the direction of a vector. Am I right? But if you multiply one by c1, other by c2, then it will change the direction. Isn't it? If you multiply these coefficient, okay, by the same scalar, that is nothing but you are multiplying the scalar with a vector, okay, direction of the vector is not changing. Are you getting my point? So just grab this idea. So since direction of the vector is not changing by the multiplication of scalar, I will just multiply with a scalar so that I need to do some manipulation here. Later I will normalize. I will make it unit length. Exactly the same thing I am trying to do here. Are you getting my point? I need root of 2 by a here. Okay. Again, you can't multiply root of 2 by a here, nothing here. That is not allowed. The whole thing can be multiplied by root of 2 by a. Or you can multiply by root of 2 by a, you can divide by root of 2 by a. Again, that's lengthy. I mean, one step lengthy. Or when you take mod c1 square, mod c2 square, unnecessarily you may get into trouble actually. Are you getting my point? You explore this what you call linear algebra concept. What is the concept? If the whole thing is multiplied, again, If this is multiplied by one constant, if this is multiplied by other constant, then direction of the vector, just like direction of the vector changes, state itself changes here. Okay, if whole thing is multiplied by one constant, so state will not change. Okay, state magnitude may change, I mean its length may change, but direction will not change in the sense of what you call this arrow vector. Okay, so later you are making again c into a vector, you are going to divide by mod of c into a vector, you are making it as unit vector later, isn't it? That's a what you call process of normalizing. Is that okay? So that's why always try to, again, always feel free to throw one term constant throughout this linear combination. So this weightage should be the same. Weightage, are you getting my point? The ratios should be the same. That ratio decides the vector, isn't it? Just like if you have a vector A, okay, I cap, j cap. If you write A is equal to ax I cap plus ay j cap, okay, how do you write its orientation? Tan theta is equal to ay by ax. Speak up. That means ratio of this coefficient will decide its direction. This don't affect this ratio while multiplying by a constant. Don't affect the ratio. That ratio contains some physical property, direction. Is that okay? So try to explore some linear algebra concept here so that you can do the problem in a quick way. Okay, look at here. What I do is I will keep a as it is or some other a, some other constant. I'll take root of 2 by a here. Sine pi x by a plus 1 by 2 root of 2 by a sine 2 pi x by a. Okay. So again, you can, to balance this one, you can multiply by root of a by 2, but that's not required. You have multiplied the whole thing by one constant. Am I right? Feel free to do that. Pick up. Or if you multiply by root of a by 2, suppose to balance that one, so that you get into this one. So club these two terms, take it as other constant. Anyway, you are going to find it by normalization. Are you getting fine? Anything is okay. Either you dare to multiply the whole thing by one constant, keeping a as it is, or whatever the balancing factor a by 2 you get, you just try to absorb that one to a, write it on a dash. Find a dash by normalization. Don't keep this one because not, I mean, so good while doing that algebra. Okay, speak up. So that's equal to, that's why I'm going to write like this. Okay, or a prime. Speak up. So now this is equal to a prime into, okay, psi 1 plus half psi 2, isn't it? Speak up. This is psi of x comma 0. How do you normalize? I never went for integral way of normalizing. I'm doing all algebra here. Okay, pick up. How do you? So this is C1 is a prime, C2 is a prime by 2. Am I right? Mod a prime square plus mod a prime square by 4 is equal to 1. Am I right? Mod C1 square plus mod C2 square, that's equal to mod a prime square 1 plus 1 by 4 is equal to 1. What is this one? A is equal to a prime is equal to, I think 4 by root of 4 by 5. Am I right? 2 by root 5. 2 by root 5. You got exactly the same thing earlier. Am I right? 2 by root 5. Speak up. A prime is equal to 2 by, don't substitute the same thing here. Okay, I'm just saying I just normalize this one. So this is equal to, speak up, 2 by root 5. This is the normalized state. This is the normalized state. Is that okay? Speak up. Shall I rub it out? I hope you got the logic here. That's equal to 2 by root 5 psi 1 plus half psi 2. Speak up. You got the same thing earlier also? 2 by root 5 psi 1 plus 1 by root 5 psi 2. Now, for any further process, okay, you don't deal with that one. You deal with this one for any expectation values, measurement outcome and all. Isn't it? Now, what is the question? What is the average energy of the system? What is the average energy? Average energy of the system or expectation value in the what you call a more accurate manner, or expectation value of Hamilton. That's nothing but only C1, C2 are non-zero. Rest of all terms are 0. Okay. Mod C again. make sure that it is normalized. Otherwise, this expectation value, whatever you are writing, that would be wrong. Okay. Mod C1 square into E1 plus mod C2 square into E2. What is this mod C1 square? 4 by 5. You lost one mass. 5 square h bar square by 2m square. Plus 1 by 5. 5 square h bar square by 2m square. Okay. E2 is I lost mass. 4 5 square h bar square by 2m square. Okay, this is twice of that one. Am I right? So that's why let me write it here. What is this one? 8 pi square h bar square by 5 into 2m square. Now look into options. 5, let me keep 5 here. I'll keep 4 here. Okay. Third option. Is that okay? I've done algebra, only algebra. Even it was not normalized. I've done only algebra to normalize also. Speak up. Can you grab the points? Concepts. Speak up. Where these are normalized eigenfunction. Okay, speak up. Fine. These are normalized eigenfunction. Or you can take ortho normality. What is this one? Phi n star pi m dx is equal to delta m comma n. Okay, speak up. So you wrote this psi of x, okay, in terms of summation over, I'll take n inside, okay, n equal to 0 to infinity, some quantum number, okay, speak up. That's equal to n into 1 by root 7 power n times, okay, pi n of x, okay. So that equal to, I'll see it as n equal to 0 to infinity cn into pi n of x. Speak up. The normalized wave, this is a normalized wave function. If it is normalized wave function, what is capital? Okay, what is the normalization condition here? Summation over n equal to 0 to infinity. Okay, speak up. Mod cn square equal to 1. What is cn? In place of cn, you have this one. Okay, speak up. What is this one? Summation over n equal to 0 to infinity. So n square or mod n square. Okay, 1 by root 7 power 2n equal to 1. Okay, speak up. Now, so this is mod n square. You just have to do this infinite series. It's not a big deal. Check this out. You just have to neatly write that one. Sometimes we feel like, okay, we don't know this infinite series. You write down a couple of steps. Think over it. Now look at here. I'll take square inside. Okay. What is that one? 1 by 7 power n equal to 1. What is this one? What is this one? Power 0, that is 1. 1 plus 1 by 7 power 1. Okay, plus 1 by 7 power 2 plus 1 by 7 power 3 plus and so on. What is this one? Can you recall binomial expansion? Speak up. It is 1 by 1 minus 1 by 7. 1 by 1 minus x, am I right? This was summation over n equal to 0 to infinity x power n. 1 plus x square and all. So that's equal to 1. Am I right? Right hand side is 1. Fine. That's a binomial expansion. Okay. Speak up. So mod n square, what is here? 7 by 6. 7 by 6